This is working probably. We think that because this is probably working. I think it is. And this is probably. Yeah, it seems like it's the mathematical methods class, right? And we will do mathematics as far as we could, and we cannot cover everything in mathematics, but we will be doing some important stuff that we need in quantum mechanics and related fields, because you know that physics is based on mathematics. The theory of physics and understanding nature of phenomena, that is all based on the understanding of mathematics as far as physics is concerned. And remember, mathematics is a language. Mathematics is a language. It's a language of symbols. It's a language of symbols. Right? Plus means something. When you say 1 plus 2, so this plus means something. It means a process of something, and which we call it a process of addition. So it's a language of symbols. Plus means a whole concept. The process of addition. Similarly, minus means the process of addition of a number by the inverse of it. Right? So it also has addition in it. And similarly, division means division is represented by a parallel dash, horizontal dash, and there is a dot above and there is a dot below. So that means that you divide one number by another. Right?
Yes.
Similarly, multiplication. These all symbols mean something. This is like primary arithmetic.
Yes.
All this primary mathematics and primary arithmetic, this convey a message like a Chinese language. You know, Chinese language, people say it's a language of symbols. Right? Because the Chinese language grande, mathematics will get English grande. Right? So, it's a language of symbols. It talks to you. Mathematics talks to you. When I look at an equation, it talks to me. What it wants to say. So everybody should be like, an equation should be talking to him. An equation should be giving him a message. If that's like coded language. It's a coded language. Words are coded. So you have to decode this in your mind, and we will have decoded in our mind. And the meaning we will obtain. Otherwise, mathematics is nothing. It's just ulte seedhe. Right? If you look at your integral sign, integral sign does the sort of
Summation of smart thing.
right? That's it, you know?
Yes.
और साइन बता दो तो इंटीग्रल साइन नाम से मतलब रहा उसको गुरु दा डिवीजन परसेंट बिफोर इंटीग्रल साइन does it easy? If you look at this looks like S, which means summation, right? So there are links in things, and usually symbols give you some meaning, right? So I hope that by the end of the course, you will be able to get meaning of some questions, right? And interpret an equation to someone. Kusuk lara ke sarero wande rakshi jayur de chagat tasuravi bandi poe ko de sei ya sub zamidar de ya sub dukandar de agat tasur equations meaning ko de sei. Because it's a language. If you are good in it, you will be able to convey the meaning.
Yes.
If you are a good translator, you should be able to convey the meaning to a poor farmer. Right? So, look at mathematics. There are two things. Learning and remembering. Learning and remember. Learning the arrangement of different symbols together, how they, when they are arranged to each with each other, what do they convey the meaning, and similarly each symbol, what each symbol represents, that's all remembering. You have to remember this symbol represents this thing, and then the two symbols or three symbols or four symbols are mutually mixed together. So that's a complicated situation, and then you will have to get a meaning out of that picture. Right? So I hope that you will go with me, along with me, and try to learn mathematics as far as our own course is concerned, and the requirement of the subject of quantum mechanics, electromagnetism, and mechanics, right? Other branches of physics are concerned. So the course here we will like probably the code for this is PHY712, I believe, right? That is the code of our this present course, and the name of the course is like maybe advanced mathematics or something, but what I have been conveyed is they call it mathematical methods. I know, but there should be like maybe advanced mathematics or what, right? And our semester maybe will be ending like starting from February, should be ending February, March, April, May. Something like in the June we will be giving you an examination. Yes. Right? So it's a 4 month course, and in this course we will be trying to cover different things. Let us hopefully you know my name, right? And you know, I can give you my number. That will be just to convey some important message. So it could be like, should I write it down, or you can take it from verbatim, right? So I hope you, when you need my phone number, that's just for giving me a message. So you dropping me a message, right? And the book, that the textbook I will see, which we will follow, right? That will be mathematical methods for physicists. Mathematical, right? Methods for physicists. Right? By G. Hoffman. Right? And H. Weber. Right? And we will have our class, as you know, that will be like Monday to Tuesday, right? And from 10:30 to 12 p.m., right? Okay. There are other books which are good books, right? You can read like Methods of Theoretical Physics, right? Morse and push back, and mathematics of physics and chemistry, right? By Mark. I believe this is not working very good, so I can put it here. And mathematical methods of physics by Matthew and Walk. And there are many other books, right? I also prefer like a book that is kind of a bridging book, like they by the Cambridge University Press. It's mathematical methods for physics and engineering, a comprehensive guide. Comprehensive guide by Riley, Hobson, and Betts. Quizá debe ser una representación. So this is kind of the list of helpful books, and there are so many other books. You can find anyone, and they have good. I believe it should be good for your purpose. Okay, so exam and grading, right? So attendance, right? That will be 10%, right? Mid exam, that is 30%, right? Final exam, that will be 50%, right? And MCQs and quizzes, that will be 10%, right? So this is what we have to follow this course of line course. Okay, so now variables. Right? We will do the complex variables. Complex numbers are very important. That's the other complex numbers are very important thing. What is the benefit of complex numbers?
Which original is number.
Right, done, good. And
Consist of real and individual.
right, right, right. Look, the main purpose of complex number that it serves is probably to differentiate between two waves that have phase difference. So the main purpose that the benefit, not the purpose, but the benefit will be like to take care of the phase difference between waves or the phase difference between periodic functions. The phase difference. You know, phase difference is a particular moment of, at which a certain point of a periodic motion is in a certain angular position. You know, for example, this is a circularly moving particle, the tip of my finger, right? So this is moving. If it's a simple situation, I can easily handle maybe. But if there are two waves and two particles and they are moving one after the another, and they are, their frequency is different, so one will be moving faster, the other will be moving slower, and one will be at some time going ahead of the other, and then so the phase difference between the two will not remain constant. In this situation, complex numbers help us a lot. They simplify mathematics of circular motions. Simplify a lot. They simplify complex variables or complex numbers, simplify mathematics a lot to solve difficult problems. Right? So complex numbers are very important, are very useful in circuit analysis, in which there are many particles or bodies moving in a periodic way. Right? So in this situation, we use complex variables to describe the motion of those particles which we take as a whole, as a system, and they have different parameters characterizing each particle. Right? So in those situations, dealing with this complex phenomena, the complex variables are a part of mathematics that helps us a lot. Right? So we are doing this. Let us start from okay, so before that, let us do some series understanding. Right? We said sine x is equal to x minus x cubed by 3 factorial plus x 5 factorial and so on. This is how we define the sine function. This is how the sine function is expanded. This is how we understand sine function. Right?
Yes.
Or if we write this in a symbolic form, right? We say sine of x will be equal to summation. We write this thing again in a symbolic form, right? So instead of writing a whole line, we write it in symbolic form, which is minus 1 to the power n, x to the power 2n plus 1, divided by 2n plus 1 whole factorial, n is equal to 0 to infinity. This is how we define sine of x, right? Similarly, cos of x, cosine function, right? That is equal to, that is equal to 0 to infinity minus 1 to the power n, x to the power 2n, right? Or 2n factorial. This is how we define sine function mathematically and cos function, cosine function, right? So we should be remembering these things as well, because in mathematics we will use them on and off at different point of solving problems. Similarly, right, we also can expand the exponential function. The exponential function can be understood like this. 1, it starts from 1. The exponential function starts from 1 and it is equal to 1 when when is the situation when this will be equal to 1? Yes? 0.
X to the power 0.
When x is equal to 0. When the variable is equal to 0, the exponential function is equal to 1. And the variable increases from 0, then it changes. Right? So, 1 plus x, right? Plus x squared by 2 factorial plus so on. This is the exponential function, right? Okay, we can write this in a symbolic way, right? X to the power n or n factorial, and it starts from 0 and goes to infinity, right? E to the power n. Similarly, you know from your basic mathematics, where if you know minus 1 square root, if minus 1 square root is equal to I, right? Then e to the power ix, right, is equal to, right, ix to the power n or n factorial. And it starts from 0 to infinity. Right? Just putting ix instead of x in this part. Right? I can write this further. I can split this. This is a series. This is a series. And I can split them in odd numbers and even numbers. So there will be 2 lines, something like that, right? So can I do it like that? Ix to the power n or n factorial, even number, n is equal to 0 to 4 to infinity, plus, right, sigma I x to the power n or n factorial, where n is equal to 1, 3, 5. So I split this into series. One series, I split this one series into 2. Right? So now I want to put a dummy variable in this. I will just put a dummy variable so that see what happens. What's your W variable? Put a W variable, right? Variable. Okay, just change it to another variable. That variable means, it will not mean anything, but just face potential. W variable means just change the face of it. W variable, let us replace n by 2m, right? That is replace n by that is the fully form to you. We want to write this in a simpler form. That is why I'm replacing n by 2m. جماعة الآخرين result today أنا كيسة guys. See? So I will write e to the power I x equal to, right, ix, and that will be 2m divided by 2m factorial, right, and 2m is equal to, for m we like 2, right? So 2m is equal to 0, right, and 2, etc. all these things, right? The n was 1 declaration, right? When I look, okay, wait a minute, okay? Plus I will, right? And minus 1 to the power n, and x to the power, right? 2m plus 1 over 2m plus 1, right? And m is equal to 0. Look, when m is equal to 0, it starts from 1, right? When 2m is equal to 0, it starts from this. And when that's a good idea. Shiga 2 tira, shikana 4 shiga, the n is equal to 2 rashi, n is equal to 2, and several hours n is 2 rashi. Okay, right? N3. So it is like 4 as I said, right? 2m is equal to 4 shiga, n several hours, 2 hours shiga, right? That didn't so we replace this, right? So when 2m is equal to that's equal to mathematics for anything, n is equal to 2 shiga.
Yes.
Right? That's my first name. Okay, we will chap running. We will be running. Chap for children. Okay, so look, e to the power ix, right, will be equal to, right, that belongs to a cos function, and this is sine function, right? So it will be cosine of x plus iota into sine of x, right? Cos x plus iota sine of x. That is how we split. Look, this is sine x, this is cosine x. See? Look, this is like that, and this one is like the other part. Now we are going to write them in a compact form. Write both the series in a single symbol, or single symbol essentially, that is this. You can write this for both of them. Instead of writing this and this, I write only how you combine sine and cosine. This is the benefit of the complex variables, which is ix. For ix pakai nare, kita sudah biasa split kalau kita dijorkan. You cannot split this to contain this. Dena lana sheraste. Ho dena the that magic then this is the iota. This is the benefit of iota. This is the benefit of introducing complex numbers or complex variables in our case. Because this is a variable. So in the form of complex variables, we can put two other functions into a single notation, and which will make mathematics very easy. Because given the derivative of like d by dx or b d by f, like this is a lot of mathematics. So that's the derivative of like it's very simple. So this is another benefit of using complex variables. Now we can replace, right, x by minus x. Replace x by replace x by go to the other side of the scale. X positive this direction, x negative this direction. So let us move to the right, the left. So that will be e to the power, right, minus I x, and that will be cosine of x minus iota sine of x, right? Okay, look, we represented sine and cosine functions in a single symbol. Mathematics with these two is difficult as compared with doing mathematics with this one. That's a differential apply. The differential logic, the differential logic, or the differential apply. So mathematics becomes easy and compact, right? Which we can do another trick with this. Trick correlation. Cos function can be represented in terms of this. Cos function can be represented in terms of this simple notation, right? So cosine of x, so that e to the power ix plus e to the power minus ix divided by 2. So what's that? This time.
Sir, I have one question, sir.
Okay.
Sir, मतलब the sign sir iota है cos sir iota मुझे बड़ी नहीं
This is how it is made. Then that is it. Did that's the what? Then that's it. 4. 5 to because it adds to 4. Therefore, when we start this iota on the or this over again. This iota on the this over again. You are just crashing the room over. Conversion over again. Haider, conversion the conversion correlation. For दासी convention जोड़ सवाल है. रिवाज दासी जोड़ सवाल है. Convention दासी जोड़ सवाल. और हम को क्या तरह से देख रहा हूँ? से 8 to ना तरह से करो. मुझे तो खुदिया बड़ा समझला किसका? When we saw that, we added two things together and gives you result. Because it is the two-way. So this way, yeah. So this is how we got it. By this splitting this. Splitting को two MW variable थी तब आवाज तो चिदार में सरा I की राशि बन गई और चिदार का cos की राशि होता था sin दुदा मतलब exponential split को चिदार single cos को sin की राशि तो cos और sin तेरा उधर व्यवहार I दे सरा राशि दाले splitting बीते बारे लगनोर for the last year कोशिश बंदी होगी and there are more questions I hear right also. So another benefit of the complex variables is that we can write cosine function in a simpler form. This is a lot easier when you do differentiation. Right? Okay, sine of x e to the power that is जो ना केगा 1 fi केगा via बताया सीधा लिखा minus I x divided by 2 पूरा दासी करो कि e to the power I x वाला को expand कर देना है किचुम लगा वाले expansion करेंगे the expansion ओके दा देना मनफी के 2 वाले divide के इधर function बताया आगे definition करो तो रश में now another trick. Let us do another trick. Let us do another trick. The super idea खराब मत लिखो. कोला सुन लिखी. अब स्लो स्लो लिखो वर्ड लिखना. I want to go fast, right? Oh, that's fast one. एक number है going fast one. That's it. So let x is equal to n theta. Yes, where n is equal to 1, 2, 3.
Sir, could you iota be sin is?
Data.
Yes, learn using the 12.
12, yes.
Yes.
What is your data?
Divide by 2.
That not happen cut. Now, show bulb. Zara ختم شطور أولا ما تبي جدا كل ما خلنا ها راو روستا وما كان إذا طول ما بسان زارا أنت كذيك لا شو هاي ذيك أنا توصل
Yes, sir.
yes thank you so let us put x is equal to n theta where n is a number and what is theta? It's a radian, right? Which we may call angle. Angle is a radian. It starts from 1 degree, 2 degree, 3 degrees, 1.5 degrees, 1.9 degrees, and so on. Right? So let's x is equal to n theta e to the power I n theta equal to cos of n theta plus I sin of n theta. Same? Huh? Left hand side. This theta to value. This is your cover on credit. Yeah, don't see can I? Theta way demise them. D E M O I demise. I V R E. That's ما كان يقول لنا وين mathematics. ده basically في سيكم اشتغل. وده في اسمه demise theorem. ها؟ that's pretty good. That's study the that's what is it. In the old chapter of Pazeva Nimu ka, or the new chapter Pazeva Nimu part. No realistic.
Yes, sir.
If we is in that routine. बाहर दुनिया और तलख करें ये बाहर दुनिया इसका अब तो रस्तोई क्या हो रहा okay so this is called demise theorem in basic mathematics right
Yes, sir.
so we can prove it we can show it how this comes out to that demise theorem cos e to the power I n theta equal to cos
n
plus
N.
right? So left hand side e to the power I theta n that can be written is e to the power I theta to the power n right? And that is cosine of theta plus iota sine of theta to the power n right? This is actually the demise theorem. E to the power I theta to the power n is equal to cos theta plus iota sin to the power n. The same thing. And this can be done by binomial expansion as well. تصوير slow بيا مخلوي ها ده بس هو ده complex numbers right complex numbers you remember it very well looks like okay complex numbers they are an ordered pair of two numbers ordered pair you cannot change the order ordered pair means when you change the order you change the meaning so the complex number is an ordered pair right of two real numbers single a b this will be a complex number an ordered pair of two real numbers which is further written as a plus iota b which will mean that a plus iota b right and complex variables right and ordered pair of two right variables right x y let us assume numbers here right are other way x plus iota y and complex number is represented by a symbol कब symbol का represent किया आमतौर complex number iota is a minus 1 square root
Yes, sir.
it's called imaginary part when iota is combined with a number or a variable
Yes, sir.
in a multiplicative form it is called the imaginary part of a complex number right so x plus iota y this is called represented by z
Yes, sir.
right complex function an ordered pair of an ordered pair of right two an ordered pair of two real functions हम उस पता से function in the page an ordered function of two real functions function page definition chapter was a function true definition of a function this is and a complex function can be represented like function of the complex number a complex function is function of a complex number right that's so definition of precise level is good precise definition دي او بياخد relation او function كفرق مش كولاج ترى precise definition ولا زي تسوي ده طريقه relation كم سيدي relation definition او function definition لو بفرق سنه
One is precise and the other.
no precise means nothing precise तो गजरगुरु जो बता या दुकानदार जो बता या बस precise पढ़ो तो मतलब नहीं we speak in functions are defined in a relation between two sets of members of numbers or arrange plan rules Nubia function de, ke planning nubia relation de, ke dar se nubia da se ya ko reka. That's a function.
Two functions जो हम लोग पढ़ते हैं.
Look, go ahead, go home and try to learn what is a function. Dah calculus kita ABC kedua lagi, number function definition lagi. Calculus kita suruh koi number lagi. Definition of a function. It is a rule of correspondence in which each and every element of a set A is made. That's right? Calculus tabalar se function definition berbuat. और टेस्ट करता रहा और जब तक रिलेशन और फंक्शन के सफर करते चिबिया दस को पता नहीं जब तुम्हें चिता रिलेशन दिख द फंक्शन दे so a function of a complex number can be written as this iota xy sorry and we also accomplish variables, we also talk of the Argand diagram. Argand. This is just a review of basics. How the zikr between zikr अंतर क्लास की उल्टा सीधा पढ़ना. तब सुबह किताब सारा बेच करेगा. If written in a book, that is true. If said by me, that is wrong. If there is a conflict between I have said something and the book says something, so there is a 99% probability that I might be wrong and the book is true. Okay, so Argand diagram represents a complex number, a complex variable, right? It represents a complex variable, right? So it is usually a plane. Argand diagram is a plane in which there are two axes. Ordered pair लेकर बोला. Ordered pair, two axes, two variables in which order is important, right? So generally, this is taken as x, and this is taken as y, and you represent the complex number z, right, as x plus iy. X plus iy is z. X plus iy is z. A vector summation. And the z is making some angle theta with the x-axis. The complex number is making, this complex number is making some angle with x. The complex number is making some angle with the x-axis. Look, the complex number is making an angle with x. It is also making an angle with y. But the convention is that we use it with x. That is, will be the way everybody is doing it. Right? And this is called R, right? Which you may call the radius of a circle described by the tip of a complex number. You know? Right? So, if we resolve this in according to vectors laws, so we will say x is equal to r cosine of theta, right? And y is equal to r sine of theta, representing the real part, right? This is all radius, this is called the radius, and this is called the angle. Circular. It is also related with the polar coordinates, right? It's not very so we also say that x square plus y square is equal to r square. You know, do it by the Pythagorean theorem, right? called magnitude of the complex variable. Right? And theta, that is called, so R is equal to Z. Magnitude, this R is called the magnitude of the complex number. So it is denoted by Z modulus in the modulus sign. Theta is called the phase of Z. The phase of the complex number. Theta is called the phase of the complex number, right? Similarly, we define complex conjugates. Vamos trabalhar apenas na definição, você falou. Tutto per una mossa tratta lì. C'è poco alcune di sicuro. Okay. Here is another thing we use conjugate. English dictionary answer that's all. Particularly in Sigolo, most of us whatever dictionary they talk. Actually, ऐसी रस्म नॉर्मल मिला लेकिन ना अलग भी कारखानों तो तलब electronic dictionary में मतलब था electronic dictionary. It was 1992 or something. The electronic dictionary में मतलब अमेज़न वाला था आरम्भ करने जैसे करता. Our words game book के ऊपर dictionary is very must. It is must. Our tool, science or physics for dictionary, keep that. Our language for other. Conjugate stuff for dictionary, talk it about it. That's what I'm meaning then. Right?
Yes.
It's one of a pair of two. Right? Kind of. If Z equal to x plus I y, then something complex conjugate. Complex?
X minus
Yes, conjugate.
Yes.
That is called Z bar is equal to x minus I y. The terminology was the Z bar product. Right? Let us see. Z bar product. That would be x plus iy and x minus iy. Right? We have a sheet. X square barashi. Yeah, minus ixy barashi. That will be plus ixy barashi. That's the barashi. No x square plus y square barashi. Right? Oh, they don't want to r square. X square plus y square से बराबर दे. बराबर x square plus y square r square बराबर है. X square plus y square is equal to right? Oh, R is the magnitude. R is the magnitude, right? So R square will be the modulus of the square of the modulus of the complex number. This is what? The modulus of the complex number, a complex variable, not number. The complex variable represents what? The magnitude of the complex variable. Right? Okay. If f is equal to u plus I v, then f bar, which is the complex conjugate, will be written as u minus I1. Same? Huh? Okay. Look at this. This are this. Look at these two, right? From here, right? We see that. Sorry. Okay, so the modulus of z, which is the magnitude.
Yes, sir.
The magnitude of a complex variable is greater than or equal to the real part of z. It is either greater than
Or equal.
or at the least equal to the real part of z. Look, if this is equal to 0, then f is equal to u, which is the real. If it is not equal to 0, then it is greater than u. Right? So the modulus, what is the modulus? The modulus kula should sir. X square plus y square root should sir.
Yes, sir.
So that is always greater than the now to xy character xy. So z is equal to 0 if y equal to 0. Right? Therefore, there is an equality sign. And z modulus, right, is greater than or equal to the imaginary part of z as well. If it is the other way around. If x is equal to 0, then it is equal to the imaginary part of z, right? And remember, the imaginary part of z means what? Imaginary part of z. Imaginary part of z. Why can zero by not away? Yes. But imaginary part was equal to some complex variable. So the advanced mathematics. This is imaginary part. Y is the imaginary part, and x is the real. Imaginary or no variable thing. It is a number. Minus 1 square root thing. Which as I margare in the substitute the real part na imaginary choose check right? So let us make some comments. That was also asking class again. Some top asking, no, top asking. Now we give away. Complex variable summation is commuted. Z1 plus Z2 is equal to Z2 plus.
Yes, sir.
We have to remember these properties.
Yes.
That was a mumbia or waqt safety ki pakari. Kal koi kalima bayan dawe kana kafir was began pakari. Therefore, the properties we are don't worry because they will help us in solving problems.
Yes, sir.
Right? So they are commutative with respect to addition. Similarly, commutative with respect to multiplication too. Right?
Yes, sir.
Also, they are associative. Z1 or Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. Right?
Yes, sir.
Similarly, associative with respect to multiplication, Z2, Z3 is equal to Z1, Z2, and Z3. distributive. This is called distributive with respect to addition. Right? Z1, Z2 plus Z1. You distribute this upon these two. That gives the dvou kasamnomias capacity. This is called distributive for two, right? Okay. Property number 2, right? If Z1 is equal to x1 plus I y1 and Z2 is equal to x2 plus I y2. If Z1 is equal to x1 plus I y1 and Z2 is equal to x. And if Z1 equal to Z2, if Z1 equal to, this means that, right, x1 equal to x2 and y1 is equal to. If the definition is this and the condition is that Z1 is equal to, these two are equal. This means that this part is equal to this part and this part is equal to this part. It means that the real part is equal to the real part and the imaginary part is equal to the imaginary part, right? If Z equal to 0, this means that the real part of Z is equal to 0. Right? Huh? And imaginary part of Z is equal to, look, if Z is equal to 0, what does it mean? The real part is 0 and the imaginary part is also. It means x is equal to 0 and y is equal to 0. Right? Okay. Property number 3. If Z1, Z2 equal to 0, if the product is equal to 0, Z1, Z2 product is equal to 0, then either Z1 equal to 0 or Z2 equal to 0. If the product is equal to 0, then it means that either Z1 equal to 0 or are they both equal to 0? That's another option. Are both Z1 and Z2 equal to 0. Right? We can prove that answer, right? If this is equal to 0, means this is equal to 0. Right? Or by multiplying, we multiply them, right? And rearrange. x1, x2 minus y1, y2. We multiply them and rearranging them. Plus I, x1, y2 plus y1, x2. And we say that is equal to 0. Saya kenal ni besar-besaran start. Right?
Yes, sir.
Okay. Then x1, x2 minus y1, y2. Look, he said, then, this implies that x1 is equal to 0 and x2 is equal to 0. Now we have heard of this is equal to 0 and 0, right? So this is equal to 0 and well, and total syllable this part because this is the imaginary one. And x1 y2 plus y1 x2 equal to 0. Both are equal to 0. Right? Now it's now Ali. Square. Let us square. Let us square. Right? So z1, z2 whole square. Right? Is this square? Right? And that is equal to 0. So here, you go this square, the square equal this square,
Yes, sir.
and this square equal to 0. So let us expand them, right? Let us see x1, x2. Does it touch pull out the square take, huh?
Yes, sir.
When you square this, r square this, the same. You will get the same result. You will get this. You will go this way. The coupled parts of the x1 to y1 so the x2 to y1 so the coupled parts will be cancelled.
Yes, sir.
So we get this equal to 0. Right?
Yes, sir.
So either x1 square plus y1 square is equal to 0. Which means that x1 square is equal to x1 is equal to 0 because both are squares. And y1 is equal to 0. When this is equal to 0 means this is also equal to 0 and this is also equal to 0. R x2 square plus y2 square equal to 0. The second part. This is equal to 0. R
This is equal to
0 are
both
both
are
equal
equal to 0.
to 0, right? So this means that x2 equal to 0 and y2 equal. Now say x1 or y1 0 show, it means z1 equal to 0.
Yes, sir.
Right? y1 0, that x1 0, that means that
Z1 is equal to 0.
the 0 0, the 0 that
Z2
means
equal to 0.
do proof on the show, brother. Because z1, z2 0 very matlab hai che either z1 equal to 0 or both are equal to 0, right? بس دا پانا خلاص کوم دا سره ولیکم
Yes, sir.
ها
Yes, sir.
سورة ټیم پاتې دی
ختم. 12
او مای ګاډ زه بیا ځل ولیکم یا تاسو په سټیټ کې واسه division 4 number part division, right? No z1 चिकन z2 बारे divide के डागे ना समझ लग रहा है the division ना मतलब था x1 x2 plus y1 y2 or x2 square plus y2 square plus दाखा ये दस टिक और के परे खोलो था y1 x2 minus x1 y2 divided by plus y2 square. يلا مذكر غير كم هذا
जी सर